Okay, can you hear me? Good.
You can just close this guy, probably.
There we go. Okay. Actually, the other thing that Andre didn't mention is that we actually had a couple of billing systems, and one of the things that gave us an impetus to get this finished in a hurry was that one of them literally disappeared, and when we sent people round to their office, there was a to let sign. We couldn't find any of the people associated with the company. We didn't know where the machines were, where the data was. We had no way of getting those bills out at all. So we had to put our right at the end of the initial round of development. We had to hurry up quite fast to get it done to replace that particular provider. Okay, so here's the platform that it basically runs on. We've got this runs on a single system that just runs Postgres. We've just recently migrated to Postgres 9. It's a quad 4 quad Xeons, so it sees 64 processors with hyper-threading. We've got 128 gigabytes of RAM on the system. As I said, we just recently upgraded from 8.3 to 9.0, which has let us do a number of quite useful performance improvements. And we have a hot standby that we set up recently, and basically we've moved all the statistics and reporting off the main production system and run that against the hot standby. The main database that we have is for the Enlightened system is 88 gigabytes. That's actually a large part of that is actually not operational data. The amount of operational data is probably of the order more of 20 or so gigabytes if we take out audit tables and a couple of other not particularly operational tables. So we're not talking huge amounts of data, but what we are talking about is an application which is quite compute intensive. The long distance data is kept in a separate database that makes things a whole lot easier for us, and it's currently running around 47 gigabytes. The load average on this machine normally runs around 7, so it's not stressed out at all. It's perfectly adequate to the task. We could actually ramp up the computation on this machine without stressing it at all, and it's probably good for several years, even if we go up to the 500 million in billings that Andre is talking about. In fact, the large part of its load is not the billing system. The large part of its load is running things like the call center. Okay, so the application actually runs on OpenACS and AOL Server, which is a fairly old and venerable system written in Tickle. One of the great advantages of this platform is that it is rock solid. It just never dies. And it's also, because it's one that is that people are less familiar with, means that the hackers are also a bit less familiar with it, so that attacks on Apache servers and things like that don't affect this application at all. This is a lie. We actually have 14 web servers that are load balanced against this system. AOL Server does not provide, well, you can actually set it up to use session affinity, but it doesn't, I believe, but it doesn't, this application does not use session affinity, and basically everything, there is no state in the system. Every connection or every query is simply run on its own, and you might issue 2 queries, one right after the other, and get a different connection each time. Okay, it does run connection pools, and they're self-adjusting in the usual way, and the maximum lifetime we have is 2 hours. And there's also a scheduling server, which is basically like a sort of cron server, and we have a lot of jobs that run in the scheduling server, and it's actually critical to the billing system. So, the billing system concepts. The first concept is the idea of a development. Everything, all our customers belong in a development, and it is basically a physical location. It could be a condo building, could be a trailer park, it could be, it's something that contains a bunch of properties which have customers. We don't have individual customers that don't exist in developments, Connection's whole business is involved in selling into particular markets in developments. If you're not in one of their markets, you can't buy services from them. Then there's a billing cycle. That's basically when their billing period starts. It's more or less a day of the month. So then we have the concept of a bill run, which is an instance of a billing cycle for a particular development for a particular month. And then we have an invoice, which is the bill for a single subscriber, or an HOA, in fact, when we get to bulk billing, for a particular provider, because it can actually be more than one provider in a development, for a bill run. Okay, and we have basically tables that relate to each of these objects. So the bill run life cycle looks like this. When you create the bill run, it enters the data quality state. And when then it runs the data quality engine that Andre was talking about. Recently we improved it quite a lot by ripping out a huge number of nested loops in PostgreSQL and replacing it with about, I think it's a 13-branch common table expression query to run the outer loop, and we got improvement of around 80%, something like that. And we still have some way to go, but yeah. So Postgres, moving to Postgres 9 helped us there. You can't get out of data quality state until you pass the data quality checks. And that's the basic rule of the system. Once you do, once you pass that, you enter draft state. And this is where rating occurs. Rating is basically the process of creating invoices for the bill run. Once rating has happened, the bill run can enter the pro forma state. This is actually a process which is triggered by the manager for the property. They actually have to press a button that says, move this to pro forma state. At that stage, rating is frozen, and they can review it. It hasn't been, if they're not satisfied with it, they can push it back to draft state and have it re-rated. Presumably after fixing whatever it is that they're not happy about, which might be the pricing of some item or what have you. If they pass it, it goes into the final state. That's the point of no return. We don't allow, except in very exceptional circumstances, a bill run to exit from final state. Once it enters final state, there's a process that runs that marks all the items invoiced so they don't get invoiced again. We send off the data to the accounting system. We spool XML to trigger printed invoices, and we send a copy of the bill run data off to an archive database. And that's it. That's when it's done. So basically, rating happens on a queue. We only rate one item at a time, one property at a time. A bill run can be put on the queue by certain users. A manager who wants to see immediately what the effect of rating this property is can say, okay, rate it now. In addition to that, the scheduling server nightly puts everything on the queue that happens to be in the draft state. So we simply re-rate every property in draft state every night. So the queue processor is in fact run by the scheduling server. So you can see that the scheduling server is actually kind of critical to the system. And basically all it does is pick an item off the queue, call the rating engine, and then go and get the next one, and so on. All right. Rating a property is done by calling one single database function. Right. This is the key to making this system fast. All of this runs entirely inside the database. There is no logic in rating that is done by the client at all. All right? And that's how we got it down from 8 hours to 3 minutes. It's a bunch of functions, and basically you say, here's a bill run, rate it. And that's it. That's all the client does. Okay, and here's basically the very high level view of the logic. We wipe out all the data that might exist for that bill run. If we had a previous rating run, we simply wipe all the data away. Then we fetch all the subscribed services and the prices from the catalogue for that customer and create line items for those subscribed services. We go and fetch the one-off charges, pay, movies that they might have seen, cabling calls, anything that we're going to charge them, any one-off item we're going to charge them for, and we create line items for those. Long-distance calls, I'll get to that, how we do that in a minute, because it requires some special processing. We do that. Third-party items, we have data that comes in from DirecTV, and basically we have to pull the data out of those tables, create line items on our invoices for them, and pass, so that gets passed through to the customer. I think we do that for Dish too, don't we? Yeah. Then we get to rating taxes and surcharges once we've got all the base line items. Finally, we fetch the balances, which we will have previously cached, fetched from Great Plains. We fetch those for the invoice. We create totals for the invoice, and we're done. Long distance calls. The long distance data lives in another database, so we actually rate the calls there, because it's a lot simpler than fetching all the data back from that database into the Enlighten database. That means that we actually need to do that, we actually need a small amount of data from the Enlighten database. And so what we actually do is we actually replicate those tables. There's 17 of them that we replicate from the Enlighten database into the long distance database. That's about 1.2 gigabytes of data. And we use Londist to do it. And it works for us extremely well. Those tables are very stable. We don't have schema changes that are going to cause us problems or anything like that. And basically that doesn't amount to any significant amount of work for us. It's basically, these databases sit side by side on the same server, and it just works very well. The rating basically happens by a DB link call. We're running rating engine inside the Enlighten database. It makes a DB link call to the long distance database and says, rate calls for this customer, and give me back the data, and it does. And we did have some performance problems with it, but we managed to find out that we had a couple of missing indexes, and that wasn't a problem. Okay, taxes. Taxes come from commercial vendors, CCH, as we mentioned. It comes in as fixed length fields, which some people might recognize as the inspiration for a foreign data wrapper that I talked about at a previous conference. It's highly denormalized, so basically it sort of says, well, if you've already come across one of these records, then ignore the next record, and all sorts of really awful logic. We have a program which basically pre-processes it into CSVs, so we get rid of all the trailing space and horrible things, and we load it into the database, usually monthly. The catalogue items will have already been marked with the appropriate text category. So, in fact, I think we now have a check which doesn't let them create a catalogue product without setting up the text category, so we can't get lost that way, which we were when we started. Okay, so the stored procedure that we have that rates text, rates line items according to algorithms specified by the vendor, including things like, do 4 rounds of tax on tax, and it's extremely complicated. I know I think my head exploded more than once when I was writing the original tax routines, and we had lots and lots of meetings to try and figure out what the heck we were actually meant to be doing. It was quite harrowing. For example, some items need to be aggregated, and some don't. And there are different tax rates that apply when you aggregate and when you don't. So you've got to look through all the line items to work out which ones you've got to lump together to run a single rate of tax against, and so on. It's yeah, and then there are different tiers of tax. So you might say, okay, we're going to rate the first 10 at 5% and the next 10 at 15%, and after that it's free, or something. You can see the sort of difficulties that we get into, and taxes on taxes. Unfortunately, also, the third-party tables are not complete. For some reason, they decided to leave a handful of taxes out of the tables. This was at the request of some telco bigger than us. And so we've actually had to create our own set of tax tables, which we maintain, which cover the counties that and states that we're billing in, that they've missed out. There's not very many of them, but it's just one of those extra things that we have to look at. And then there are surcharges as well, and we have to maintain special tables of those because they don't give us all of those. Okay. It has been a major performance bottleneck because of the sorts of logic that we've had to apply. The main thing that turned out to be a difficulty was that when we were looking up all the taxes that could apply in some particular geographic location, it was taking an extremely long time because of the logic that was involved. We've actually we now create a cache for each bill run, and we've basically got rid of most of the bottleneck. That's actually a relatively recent development. Okay, archiving. When we finish the bill, when a bill run is finally completed, we basically export the data as CSV files. We've put it in a spool directory. It gets picked up and stashed into another database, so that if anything ever happens to the Enlighten database, which has a relatively, a lot of people can talk to it one way and another, we've got the data that we actually sent in an invoice. This database, the database with the archive is highly secure. This works pretty well. Printing. We ship PDFs off to a third-party processor. We actually started off shipping XML to a different processor, but this gives us a lot more control over the format. So, in fact, we're actually working currently to change the format, but the print processor doesn't need to know anything about that because we produce the PDFs ourselves. And some of them are not printed because some people like to save paper and they don't want to get paper invoices. Okay, now data is spooled as XML, one file per invoice. We do not construct any tags ourselves. We use Postgres' formal methods to construct the XML. That makes it a whole lot safer than cutting your own. I've made too many mistakes in handwriting XML to do it any other way. So here's an example of what it looks like. This is one that actually gets the data out for video on demand usage, and this function at the bottom here is the one that will give us the data, and all this function does is wrap it up in some XML and hand it off to another function which is going to wrap all the rest of the data for the invoice, and then eventually we stash it on a spool directory. The print processing, we spool the data for final bill runs nightly. It happens at around 7 o'clock, and then we go and pick it up at around 10 o'clock. Generation is done in parallel. We could actually scale this up quite highly. At the moment, we have an 8-processor virtual server. We could actually, spool this. We could drive that quite a bit higher and get, it performs adequately as it is. Okay, we use Apache FOP to turn the XML into PDFs. It's a Java program that implements XSLFO. We have a handcrafted style sheet that basically says where to put the data on the PDFs. It's about 3,000 lines long. Okay, and as I said, we're currently adding major appearance enhancements, but the print processor isn't going to need to know anything about that. Okay, it takes us roughly on a half a second per invoice to generate the PDF, which is not bad. And then we just ship them off to the print processor by SFTP, and we load them into a special purpose database so that a customer or customer service representative that comes in wants to see the PDF can see it immediately online, pretty much as soon as it's generated. Okay, Andre's pretty much talked about how our relation to the accounting system. I see we're running low on time. Basically, Great Plains runs on SQL Server. It's a particularly horrible design with horribly designed table names. We talk to it using PL-Perl, or PL-Perl-U, in fact, using DBD, Sybase, and FreeTDS. We fetch data so that that can be rated, and then we send all this data back to SQL Server when we're done so that it knows what's on the invoices. Performance. Currently, the rating, the engine rates only one invoice at a time. We could probably make some substantial improvements by rating all the line items for a bill run at once. That's a possibility. And we currently only process one bill run at a time. We do have some instrumentation, I'm going to show you some in a second, to identify bottlenecks, and that's been extremely useful in, for instance, a few months ago we had a problem with long distance rating. We were able to pinpoint that very easily because we had instrumented the rating system. There is lots of room for performance gains. The first thing we want to do is to rate in parallel. If we do that, my view is that that'll probably be enough for quite a while. Here's some performance from the metrics that we were talking about, and you can see that of these 189,000 invoices that we recently rated, it took 0.35 of a second per invoice to run the complete rating engine. Okay, scalability. I think probably a parallel queue is the key. We might need to do some more, but that's about it. Longer term, we might need to look at processing items in bulk, or possibly sharding the database across multiple machines. If we go to billing for third parties, that's probably what we'll want to do for that. Okay. This system was initially developed by 4 people. Andre and I designed it. We had 2 other people who did most of the work on it, most of the rest of the work. This is not a team, a large team. It was more intensive than a huge effort. We owe them a lot of money and beer. Okay, it took us, with those 4 people, 4 months from the initial design, around about August of 2 years ago, to November when the first invoice went out. It's been fairly bug-free. We've had a few bugs, but none of the sort of, who are we going to fire type. Being on 9.0 makes things easier. There are a lot of things that performance improvements that we can make on 9.0 that we couldn't make on 8.3. Common table expressions is just a wonderful thing to have, let me tell you. And auto-explain. Hot standby is huge. Yeah. So here's my conclusion. I think it's been pretty much an unqualified success. I'm actually quite proud of it. Postgres handles the application really well. And this is the key. Process the data in the database. I can't emphasize that enough. If you ship data out to your clients to do processing, in my opinion, you will have a serious performance degradation. Do it in the database, ship data to be presented, or it has to go to other systems. I do it mostly the same way. That's it. Thanks very much.